Okay, comparison test is kind of a huge one on the AP test. The comparison test, and then later on in the notes, you'll see one called the limit comparison test. They're both kind of used in the same situation, so sometimes you jump from one to the other. The comparison test is by far more popular, like it'll be used more on the AP test, but the limit comparison test sometimes is helpful too, so sometimes you'll jump to that one in your homework. What we're doing is we're taking series. So we're given the series of a sub n, and we're going to compare it to something that's easy to find. And then by using that comparison, we can determine, like, if this is convergent, this one's convergent, or if this one's divergent, that one's divergent. We just have to be careful that we actually follow the parameters here. So if we're starting with this part here, if our a sub n is less than or equal to our b sub n, and if b sub n, if the bigger one converges, does it make sense that if the bigger one converges, that the smaller one's going to converge? Yes, right? Because the one that's on top, think of like two functions, a function that's on top and a function that's on bottom. If the function that's on top, the bigger one, converges, then so is the one that's below it, right? So that's what this is saying. If b sub n is bigger, and the bigger one converges, then we know the smaller one's also going to converge. Okay? Same idea here. So we're given a sub n, and we're comparing it with one that's smaller than it. If the smaller one diverges, so if the one that's below diverges, so it goes to infinity type of a thing, isn't the one above it also going to diverge? So that's what this part says. And the things that we're going to try to compare to are really simple, quick things to figure out, which are p-series and geometric series. So we're going to be using a lot of the stuff that we already did. So in using the comparison test, we must have some known series for the purpose of comparison. These are the most typical ones. It's not the only ones that we'll use, but those are the ones that you'll try to compare things to. So let's start with a problem here. Determine whether this converges or diverges. So we're going to use our comparison test here. Let's write down what's in my notes so that it gets down in your notes. For large n, the dominant term in the denominator is what? What's the dominant piece in the denominator when we have big numbers? The 2n squared, right? That's the dominant piece. It's going to kind of take over everything else. So let's write that down for large n in the denominator. Or for large n, let me write this how I have it written so I don't confuse myself. The dominant term in the denominator is 2n squared. So we're going to compare to the dominant piece in the numerator, which is just 5, and the dominant piece in the denominator. So we compare with and we just set it up the same, except for we're just going to use the dominant pieces, and this is very, very typical to use, and it's super easy, and you'll remember how to do it because you'll do it now, you'll do it in your homework here. Okay, so this is what we're going to compare to. So my a sub n is the thing that I started with, so let's just clarify that. Oops, let me use a darker color here. So a sub n is what we started with, the 5 over 2n squared plus 4n plus 3. And the b sub n is what we assigned. So b sub n is the other one here. And we have to figure out which one's bigger. So when we're comparing these, which denominator is going to be bigger? The left one, right? The denominator is bigger here. So that actually makes it what? Smaller. Okay, so we're going to say here that our a sub n is less than or equal to our b sub n. So do we want this one to converge, or do we want this one to diverge if it's the bigger one? We want it to converge because if the bigger one converges, the smaller one's going to. So we're hoping that this converges. If it doesn't converge, then we have to move to a different test. Now, you wouldn't have to write this part down, but that's something that should be in your head. Okay, we're going to see if it converges. If it doesn't, I have to move to a different test. Okay? So let's go ahead and find whether it converges or diverges. What can I do with that 5 and 2? Bring it out front, so I'm just going to put the 5 halves out front. And then what's inside there still is what? 1 over n squared, which is what type of a series? T series. And our p is equal to 2, which is greater than 1, so what does that mean? It converges, right? So this is convergent by p-series test. Any questions so far? And then we know if this one converges, we know that one's also going to converge by what? The comparison test, okay? So then we can say, therefore, the given series is convergent. And you don't have to say by what part, I'm just going to say the comparison test. On my paper I have by part I of the comparison test. If you want to write that so you can reference back to it, you can. But I'm just going to say by comparison test. So questions on that at all? And that's probably the most common one. That does not mean that's all you're going to see on there, but just use the dominant piece in the numerator, the dominant piece in the denominator. There's another one that's similar to that when we get to, well, kind of, when we get to our limit comparison test, where we'll use those dominant pieces too. Okay, the AP test loves natural logs, and I've seen this one in multiple choice questions all the time. And this one's a little less obvious than the others. Okay, so let's start by writing, notice that natural log of k is going to be greater than 1 when our k is greater than or equal to 3. Okay, when we get larger and larger, our value is going to be greater than 1. So like eventually it's greater than 1. So what we're going to compare it to is just 1 over k. So let's write this down. Because natural log of e is 1, and e is 2.7 something. And you're only plugging in 1 and 2 and 3 and 4, because you're just plugging in the integers when we're using this. So 2, it's not big enough yet. Does that make sense? Because once you get to natural log of e, then it's 1. So once it's bigger than e, does that make sense? You wouldn't have to write this sentence down on your, on your AP test. You wouldn't have to write this down, but that's why we're comparing to 1 over k, okay? So if we do natural log of k over k, that's going to be greater than 1 over k once we get bigger than 3, right? So eventually it's going to be larger than it. So this one here is my a sub n or my b sub n? A sub n. So really here I have that my a sub n is greater than or equal to my b sub n. So what am I hoping for my b sub n? That it diverges, because if b sub n diverges, the bigger one's also going to diverge, right? So what I'm doing now is I'm comparing to the 1 over k. And what is 1 over k? What type of a series is that? P series, and my p is equal to 1. What happens when it's equal to 1? Divergent. So here we know it's divergent by the p series test. Therefore, the given series is divergent by comparison test. Then you couldn't do this test and you'd move to a different test. Okay? And sometimes, I mean, most of the stuff in like 11.4 is going to be comparison test. So maybe you just didn't choose something to compare it to that's appropriate, you know? Like you get better at it as you do more of them, obviously. Otherwise, there's a limit comparison test that we're going to move to that you'd try next. So, but once we get to where there's all of them, you might just move to one of the different tests from a different section or something. Okay, any other questions on this page? Okay, so we're going to move to a limit comparison test. So we've got two series with positive terms. What we're going to end up doing is we're going to end up taking the limit as n goes to infinity. And we take our a sub n, so the one that's given, over the one that we made up to compare it to. And we find what that limit goes to. And if c is a finite number that's greater than 0, so it doesn't go to infinity, okay, so it's got to be finite, and is greater than 0, then either both converge or both diverge. So then you can use maybe your p-series test or geometric to figure out whether it's converging or diverging there. And then the opposite one's going to do it as well. So our a sub n here is just what we're given in there. And b sub n, what we're going to compare it to is the dominant pieces, which will just be 1 over 2 to the n. And then we're going to do our limit here. And sometimes multiple tests work, so, you know, if you do it one way and someone does it a different way and you want to check with me, you can, but a lot of times it's fine to do them different ways, and you should get the same answer, though. So I'm just taking my a sub n on top, and I'm putting my b sub n on bottom here. Okay, now we have a fraction over a fraction, so I'm going to reciprocate this and multiply it. So I'm going to put 2 to the n over 1, and then multiply it through. So really now I've just got the limit of 2 to the n over 2 to the n minus 1. And this isn't necessarily something that we've done that looks like this before, but it's very similar to other ways that we do our limits. Instead of dividing by the highest power in the denominator, we're dividing everything by 2 to the n power. And if we divide everything by 2 to the n power, I've got 1 on top and 1 minus 1 over 2 to the n. And do I know what that's going to go to? 1, right? Because this part goes to 0. So is c a finite number and c greater than 0?
Why is that going to 1? Yeah, but isn't 1 over 2 to the n of an infinity, would that be 1? No, it goes to 0. Oh, it's large. Okay.
We're good? No, you're good.
Yep.
Okay, so then here we know that it's 1, which is greater than 0. So do we know anything about converging or diverging? What does that tell us? Yeah, either they both diverge or they both converge. So we still have a little work to do. We got to figure out whether 1 over 2 to the n converges or diverges. But whatever this one does, that's what this one's going to do. And what type of a test is this? And most people say p-series because that's, you know, what we did in the last ones here. P-series is when your power is the number, right? So like here our p was 2. So this is going to be geometric. Okay, because our first term is a half, right? Our next term is 1 over 2 squared and then 1 over 2 cubed. So what's our r value? R is a half. And as long as absolute value of r is what? Less than 1, we know it converges. Okay, converges, it's a geometric, right? We don't have to find what the sum is and that stuff. It's not asking for what the sum is. Okay, it's asking whether it converges or it diverges. So then what can we conclude here at the end? That this converges. We only care about what's happening to this one in the very end. So therefore, the series, I'm going to say the given series, these are two different tests.
Yeah, no, I was just going over the other two we didn't have to find it, but another didn't have to follow the other side.
Oh, okay. So this is by the limit comparison test, not the same. Okay, so with this one, we're going to do a similar thing to what we did earlier, where we're just looking at the dominant pieces. Okay, so our A sub n is this piece here. And then our B sub n, we're going to use the dominant pieces. So what's the dominant part of the numerator? 2n squared. And the dominant piece in the denominator would be which part? Square root of n to the fifth, or n to the 5/2. Everyone okay with that? That doesn't mean you have to keep it written like this, because once we have the dominant pieces, a lot of times you can actually do some simplifying there. So what's that going to simplify to? Two over n to the half. Does that look okay to everybody? Okay, but when I'm comparing these to figure out which one's larger than the other, I would look at, the ones that look more similar. So if we're doing just the plain comparison test, you could compare these two. And sometimes when you do this, there's like, oh, there's an extra piece in the numerator and there's an extra piece in the denominator. So then you have to try to figure out which one outweighs the other. Wouldn't this numerator, the 3 times n, end up being bigger than like that square root of 5 piece that's missing in the denominator? So if you're using just comparison test, I would say that A sub n is bigger than or equal to B sub n. Okay, and we could go about it that way. We're going to try the limit comparison test so we get another practice with that. So with limit comparison test, I take the limit and which way do I stack them? Which one goes on top? The A sub n goes on top, so we got 2n squared plus 3n. So we've got that piece dividing by B sub n. We're going to multiply by the reciprocal. So I'm just going to write it as n to the half over 2. And then we're going to try to take that limit. So I'm going to apply the n to the half through to both of those. Couldn't you just take a square root? I'm not sure what you're, like, leave it factored out, is that what you're saying? I'm going to multiply it through so taking the limit's easier. What you're thinking there. Okay, so we're going to multiply the n to the half through, so we get 2n to the what then? 5/2 plus 3n to the 3/2. And then in the denominator, I'm just going to leave the 2 out front, and we've got this. Any ideas on how to actually take that limit? Kind of similar to what we did on the last one, only this is more like what we've done in the past. What's the highest power in the denominator?
N to the 5/2.
N to the 5/2. So, yep, so we're going to divide everything by n to the 5/2. So if I divide this by n to the 5/2, I just get 2. And then this is going to be 3 over n, right? And then down here, we've got 2. And you're not dividing that by the 5/2 because this is times this part here. It's all like kind of one piece together. So instead of applying it here, we're going to apply it to this piece. So this will be 5 over, oh, sorry, I got a square root. I lost my square root there. And this will be 5 over n to the, no. When we're dividing by n to the 5/2, that's what we do when it's not under a square root. If it's under a square root, what are we actually dividing by? N to the 5th. Isn't that the same as n to the 5/2? So we're dividing by n to the 5th underneath there. Okay, so here this will be n to the 5th, and then this will just end up being what then? 1. So won't these pieces end up going to 0 because it's infinitely large in the denominator there? So I just end up with 2 in the numerator and what in the denominator? 2. So I get 1. Is that greater than 0? Infinite? Yep. So then that tells me what? Yep, they either both converge or they both diverge, so we still have to find this piece here. We got 2 over, so I'm just going to take the 2 out. 1 over n to the 1/2. That's a p-series. P is equal to 1/2. So what does that tell you? Diverges. So divergent p-series, something like that, or diverges by the p-series test. So then, therefore, this is going to be divergent by what? Yeah, so therefore the given series is divergent, sorry. By the limit comparison test. But you can't always do that one, so you have to have some practice with this too. But with this particular one, I mean, I just did it quick in my head to see if it would work, and in my head it works. That doesn't mean once I do it on paper it always works, you know. So if it doesn't, if one of them doesn't work, try the other one. But I'll let you start on your homework there, and then tomorrow we'll do questions on it, and you can work on it. So try to get as much as you can done. You can always work on the opposite odds tomorrow if you aren't having trouble with it, because it's just going to make you more prepared for the next sections coming up here.
So